Hello, welcome back to 14 Minesweeper variants 2. Yeah, we're looking at some more new variants. Well, this is the demo, so we're only having 4 new variants here, but we went through the first 3 before, and I kind of gave out at the last variant because, oh my goodness, what a variant it is. I haven't actually played a single level, so let's look at the rules of this variant. Actually, I can click here. There you go. Product. Clues represent the product of distances to the nearest 2 mines. So here you can see, well, this one is very simple. It has a distance of 1 to each of the mines next to it, and therefore the product of those 2 distances is 1 times 1, which is 1. Here it's a little bit more complex, where this distance is 1, but this distance is actually the square root of 2 if you use Pythagorean theorem. And therefore the product would be 1 times square root of 2, which gives you root 2. This is, well, there's a 1 here. This distance over here would be root 5 if you use Pythagorean theorem again. And therefore your distance is 1 times root 5, which is root 5. And this last one here, well, because of what we know from here, this distance is root 2, this distance is root 5. If you multiply that together, root 2 times root 5 is root 10. And yeah, you can see that, oh my goodness, this is gonna get really confusing. Also, the text here appears to be really big for some reason. I don't know why, but hopefully that's not what shows up on screen later. Right, so here this is a very normal 2, which is 1 times 2, but this is a more special case in which the distances are root 2 and root 2. Multiply those together and you just get root 2 squared, which is 2. So yeah. Okay, it is kind of big, but I think it's fine. It's not as bad as there. Okay, can I click any of these? No, so I guess we're starting off trying to figure out what's going on here. Is a 1 always a 1 times 1? I want to prove that a 1 is always a 1 times 1, and how I will do that is assume 1 is the product of 2 distances. One of them is a square root of something. Let's say square root of circle or something, because I don't want to draw variables here. Well, what would the other one have to be to make this work? Well, the other one would have to be 1 over that square root, right? Because they have to cancel out in the product to give you 1, right? And, well, each distance is greater than 1. So this is greater than 1, but this is also greater than 1. We know each distance is... Yeah, each distance is at least 1 away, right? You can't have anything closer to the mine than a 1. And therefore, if both of them are greater than 1, then both of them are at least 1. Then both of them have to just be 1 themselves. Yeah. Because whatever you put here, right? If this was not 1, then... If this is greater than 1, then this would be smaller than 1. I think it's a rule in math, but I don't remember how to prove it. But yeah, I think it comes intuitively that 1 therefore must just be the product of 1 and 1. So what I can say is that in this little area here, there are 2 mines. And, I mean, there could be 3, right? Right, as we can look at... which one do we look at? I don't know which one we look at. It isn't here, but... Yeah, if you had 3 mines... If all of these were mines, then... the one, I think, would just pick any 2 of them and the answer would still be just 1. So there are at least 2 mines here. I guess we'll mark that. Like at least 2. I don't know how else I'd mark that. But okay, that's a simple case. The root 2, is root 2 always 1 times root 2? How else would you make root 2 exactly? For any square root, the only way to make a product, because of that one rule where it's like square root of x times square root of y gives you square root of xy, right? I think that's the rule. This is the rule that is in effect here. And so, if this number is whatever we have here, it must be xy is 2. And x and y we know are integers, yes, because distances are calculated by the Pythagorean theorem. And all of these lengths, horizontal and vertically, are in integers because they are, set numbers of units away. So yes, x and y are integers, and therefore this square root over here must be expressed as some product of two integers. In this case, 2 as a product of two integers can only be 1 and 2 because it's prime. Yeah, exactly. So yes, this must just be a root 1 and a root 2, which means it has to be one that is 1 away, and then one that is a root 2 away. Or it could be both root 2. It could be something like this, with one of them that's 1 away. So it calculates whatever this one is, plus it calculates one of those. Whichever it counts, it doesn't matter, you get root 2. But what we do know is that there is exactly one mine here. I think. I think. And then this one here, there's at least one. So I guess we'll mark that down as well. Okay, what about this 2 root 2? Well, that's just root 8, I think. And that's because 2 root 2 is equal to root 4 times root 2, which is root 8. There you go. So this is root 8. Should I use a pen to write this down? I feel like it's way easier than writing with my mouse. Let's see if I have my pen. I have it. I don't know if it's functional, but if I just thwack it a bit. There you go. It works. Okay. This might be better with touchscreen mode, which this game also has apparently, but I'm just gonna try and talk into the mic and click on the screen at the same time. This is gonna be like a whole lecture kind of video. Alright, anyway, we know this thing over here is a root 8. Well, what is 8 made of? Whoa, okay, that is not what I want. This device, what? No, I don't want to do that. 8, sorry, is either 4 times 2 or 1 times 8. Yeah, it can't be, 2 times 2 times 2 because it's only 2 mines. I feel like 4 times 2 is way more... 4 times 2 is way more likely than 1 times 8. Yeah, because if it's 1 times 8, then one of the distances is root 8 itself. Is that possible? You gotta express root 8 as the you gotta express 8 as the sum of two squares, right? For the Pythagorean theorem to work. How is that gonna happen? Well, that would be 2 square. That would be 2 squared plus 2 squared, which is 8. Alright, so it is possible for that, which means that a minor distance of root 8 away is gotta be somewhere here. Which is possible. So you could have one that's 1 away, plus one that's root 8 away, that's possible. You could have one that's root 2 away, which is one of those cells, and you could have one that's root 4 away, which is in one of those cells. That has some synergy with the clue beside it. Yeah, in fact, it might have some synergy with this specific clue. I don't know though. Right, okay, let's look at the case where it's 1 times 8 first. If it's 1 times 8, the root 8 away can't be here because there's no mine there. It would have to be here. What does that mean? Oh, that is the next nearest mine. And that eliminates both of these from being mines because they're even closer, and we know that they're not counted because the only one that's counted would be in one of those cells. So in fact, wherever this other mine is close, with this, is actually closer to the 2 root 2, which doesn't work. Whoa, okay. Yeah, the fact that the rule is nearest 2 mines is something. So this can't be the mine that you're counting, right? It has to be this one. It has to be 4 times 2. Which means that it has to be one of those being mines plus this root 2, which means one of those being mines. And nothing is closer. Exactly, nothing is closer, meaning none of those are mines. Oh no. Oh, I see. This is really tough, by the way. But we also know that because this root 8 counts one of the mines on the outside, the root 2 that it counts has to only exist as one mine. Yeah. Oh my. Alright, let's erase all of that. We now have more clues to work with. This root 5 in particular, can I click that? I can, it eliminates that for some reason. No idea why, but I think maybe it's just programmed to quote-unquote trivialize it. Apparently that's trivial. I also wonder what the color is. Yeah, look at this color. Like the coloring colors the mines adjacent to it, except for this one, which it colors those. Okay, so one of those are mines. Let's tackle the root 5 then. Root 5 is just root 5. I'm pretty sure root 5 is 1 times, yeah, because 5 is a prime number, then again root 5 is 1 times root 5. Oh my goodness, I can't do this. Alright, so what is root 5? Root 5 is 1 squared plus 2 squared, right? Yes, so that basically means it's a knight's move away. Right, so firstly, there must be a knight, there must be a mine that is 1 away from it, which is one of those cells. There must be another knight that is a knight's move away, which refers to one of those cells. And because there is a knight that is there is a mine that's a knight's move away that's counted, there can only be one mine that is only 1 away. Otherwise, you'd count both of those mines. Which means that because this section here has at least 2 mines, there is only one here, meaning that this must be a mine. Nice, okay. That doesn't say anything about this 5 though, because even if it sees this by mine, it could also see other things by other knights moves by mine as well. So I guess that's not what we look at. Now I can say that there's at least one. Oh, there is only one. Okay. Yes, because of the root 5, there is only one mine in those cells. Alright, I think that's all we can do. So let's look at the 2 clue now. 2 is root 4. And... Whoa. And so what's root 4? Alright, I guess my pen just gave out. Yeah, it's not working anymore. Alright, whatever, I'll use my mouse. 2 is root 4, and root 4 is either 1 times 4 or 2 times 2. My guess is it's 2 times 2. But 1 times 4 is also possible. I mean, you can technically see, yeah, these are the different ways you can make a 2 work. I don't know if these are the only ways. I'm pretty sure they are. It's either 2 root 2s away, or it's a 2 away and a 1 away. Both of which will give you 2. But we know one of those are mines, which is going to be 1 away. Yeah, so... In fact, it's going to be 1 away, and the other one's going to be 2 away. So there cannot be any mines between that. So this can't be a mine then. Hey, there you go. And because we know there is 1 2 away and 1 1 away, because there is already 1 here, there cannot be anything between them again, so this can't be mine. Nice. Okay, so I guess now we can say that there's exactly 1 mine here, and at least 1 mine here. Well, that might affect the root 2, right? Because again, we know root 2 is... Yeah, there can't be 2 mines here. Because if there were 2 mines here, then it would just be 1. So there is, in fact, a single mine there only. And that single mine, plus wherever the mine is here, would fulfill root 2. One thing is that it could have another mine here, because that is the further one away. You don't need to have only one of those. You need to have only one of the ones that's nearer, but you could have, I don't know, like multiple of the ones that are further away. Okay, what about, which one have we not looked at? Right, there's 2. We need something that's 2 away, which is going to be there or there. They could both exist though, from what we know. Yeah, from what we know, they could both exist. Alright, what about this 2? Or it's either 1 and 2 away. Or because of... Oh, wait, it already sees that. If it's 1 and 2, then it sees that and that. Oh, but if it's 2 root 2s, then that's also fine. You'd have 1 root 2 in here. You could have at least 1 root 2 in here, sorry. Yeah, exactly. Okay, from this set over here, we know that there is at least 1 mine that's root 2 away. Therefore, you cannot select a mine that is just a distance of 2 away. So this 2 is actually root 2 times root 2. Which means there's at least one mine here in the other root 2 area. There's exactly one here, but there could be 2 or more here. Right, and because it's 2 root 2, it cannot see anything that's 1 away. Could I have clicked on that? I don't know. Okay, what does this mean? We have 9 mines remaining. Maybe you could do some mine counting then. This 2... Wait, this 2 was 1 and 1 away plus 2 away, but now it doesn't see that. So then this must be a mine, which means that it's not a mine. 1 must just be 1 and 1, so those are both mines, I'm pretty sure. This means that this is not a mine, because we know there's only 1 here. Therefore, this is a mine, therefore this isn't. Oh, okay. It all came together. And we're done, because there are only 5 spaces left, and there are 5 mines remaining, so they have to all be mines. Oh my goodness, that is actually so much math to do. 16 minutes for a 5x5? Are you kidding me? Okay. Well, let's look at the 6x6, I guess. Oh no, root 10. Can I click on that? Oh, it gives us stuff. Okay, hold on. Why? Let's just take a look at this. Root 10 is either... Okay. Root 10 is either 1 times root 10, 1 times root 10, or it's root 2 times root 5. Okay, I see. So, basically, you're always going to hit one of these higher bounds. Right? You're going to hit something that's either root 5 away or root 10 away. Which means that whichever you hit, you cannot go between those two values. Otherwise, it would be counting that mine instead of the one higher. And therefore, I can say that anything that is... Well, these are the low... This is the low end, right? Okay, I'm going to write this down in a better way. Anything that's on the low end, we got 1 and 2 here. Then we have root 5 and root 10 here. So, those two, for example, form one possible pair. Those two form one possible pair. And if you take a look at, I guess, a number line of those digits, of those, like, possible values, you realize that because you can't have values in between them, you can't have any of these being mines. Whichever is in here, you cannot have them being mines. And also you can't have any of those being mines, because if it was 1 and 10, again, nothing can be in between them. But again, if it was anything lower than a 2, you would be selecting this instead of the 2 and root 5. So in fact, actually, none of these values, whatever they are, can have mines in them. And so what the thing is doing here is saying that, well, since root... wait, isn't it taking these are 2 away? Oh, right, because I said this is root 2, not 2. Right, and so... I'm going to reset this. And so if we look at our values once again, we will realize that 2 is right between there. And so anything that's 2 away cannot actually be a mine. And we can actually do that for other things as well. Although, like, they're a lot rarer to see, because there is the only thing between root 2 and root 5 is 2 itself. You can't have, you can't have a cell that's a distance of root 3 away. Right, so that probably helps. I don't know if any of these have similar things to do then. No, the 2 is it's 1 and root 2. It's 1 and root 2. Actually, this 10... What is root 10 away? Can we figure out what's root 10 away? Root 10 away would be... Or it could be 3 and 1, right? So something that's root 10 away could be that cell is root 10 away. This cell is also root 10 away. So it is possible for this to be 1 and root 10, which I think is highly unlikely, but is entirely possible. It's also possible for root 2 and root 5, so something like this also works. So it could be it could be either that, which, oh, smiley face, or it could be, that. And I guess we don't know. Although I guess this would actually fulfill the root 2 very well. It's not the only way though. Yeah, another way to do it would be actually to do this. This actually fulfills both of them as well. I feel like I need to keep a list of possible distances regarding the root 2. The root 2 we know is 1 times root 2. So we know it's one of those plus one of those. And I guess we know it's exactly one of those. So, and then there's at least one of those. Oh, I think I got it. Actually, do I got it? I was like, can this be a mine? If it was, is the only one that's a distance of 1 away, you must have one that's a distance of root 10 away. So anything between that, not mine. Not mine, not mine. Whoa. Yeah, not mine, which means your mines have to be here and here. But I think that just barely works for them. So that's unfortunate. I guess this can in fact be a mine. I think something like this would also work, which means that this could also be a mine. So that's, whoa. So that's kinda, that's not really telling us much. What else do we have? Have we looked at this 1, 2 yet? The 1 is a 1 and a 1. It's 2 1s at least. What about the 2? The 2 could be root 2, root 2. So something like this works. Could also be 1 and 2. Well, it can't be 1 and 2 because we know there are at least 2 mines here. Well, sorry, we know there are at least 2 mines in those 3 cells, which means there is at least 1 mine in one of those cells, and therefore this can't be 1 and 2 because there is a mine that is root 2 away, which is between 1 and 2. So this has to be root 2 times root 2, which means there can't be anything that's 1 away. Whoa, nice, okay. That's kind of crazy, dude. The 5 here, again, is 1 times 5, so I guess we know there's 1 mine in one of those cells. I guess because of the 2, there is at least 1 mine in one of those cells now. Which actually, you know what? Doesn't that actually just fulfill the 5? Because this night smooth thing is 5 away. Yeah, so that fulfills the 5 immediately. What does that even say about anything? Maybe the root 2 then. Root 2 again we know is 1 times root 2. So what? I don't know what that means. I mean, I guess I can say that one of those are mines. Exactly one of those are mines. And then at least one of those are mines, but that doesn't really help. Oh, wait a minute. Whatever this looks at, if there was a mine here, then the 5 actually kind of gets a bit pressured. In fact, if there was a mine there, there must be a mine there. And of course no mine there. But if there were a mine, say, here, I don't know what that means. That is in fact a distance of 5 away. Same for whatever is here. So in fact the 1 and the 2 are kind of doing decent. Oh, I just realized there can't be a mine here because we know this 1 is a 1 and a 5. This mine over here would be 2 away, which is in between 1 and root 5. So that's a 1 now, which means that there is at least 2 mines in here. At least 2, yeah, at least 2. I don't know how to mark that. But I guess we don't really need to if we would just remember. Oh, right, well now this one, again, we need one that's root 2 away, so it must be here. Which I guess fulfills whatever this is looking for. It also fulfills the 10, sort of. But now the 10 could still be following... It could still be following root 2, root 5. It could still be having a mine here and a mine there. That's okay, because you could have a mine there, and I think that fulfills everything correctly. Yes. And in fact, I think this also fulfills it. Yeah, it fulfills both of them. And then on the other hand, this could also be the root 10 mine that it's looking for. I don't know. The root 2 says exactly one of those are mines. Exactly one? What if none of them were mines then? What if this one was the mine? Oh, wait, no, I was gonna say something. No, that's stupid. If that was a mine, if that was the only mine, for example, then this is a mine, and then this would have to be a mine. I don't know. Okay, let's see. There is exactly 2 root 2s here. If there is one here... Oh, I'm sorry. I'm so dumb. I didn't actually see. Yeah, it actually points at that. I mean, it doesn't help, but... Apparently, yeah, it does. Do all root 5s do that? Yeah, all root 5s do that. In fact, all root 10s also see the 2s. Yeah, so I guess if you just remember the number and the distances, you can do stuff. The root 5s and the root 10s see the things that are have nothing to do with the things that are 2 away from it. I don't know what I'm saying. Saying that this one can only have one of those being mines, right? Oh, yeah, I can only have one of those being mines, and because of this one, at least 2 of these are mines, so at least one of those are mines, which means this is never a mine. And now because there's at least one in one of those cells, this is always a mine? Sweet. And because there's only one mine here, this must be the other mine for the 1. Okay, we're getting somewhere. The 1 needs at least one more other mine in here. I don't know though. Because it already sees the one that's root 5 away, so it could see other things that are root 5 away too. Okay. Yeah, I kind of don't know what I'm doing anymore. Oh man, I gotta think hard about this one. See, because 2 only sees things that are root 2 away, it doesn't care about anything that's there, right? Because they're further than whatever its job scopes needs it to be. I feel like there's nothing here then. Like nothing here is deducible, which means you have to look back down here. This somewhat breaks into this area, but I don't know what else could be done. Alright, we know you know exactly one of those are mines. What does that mean? If you had something like this, then this happens. Actually, this 10 is already fulfilled, but I guess we now know that none of those are mines. That's not a mine then. If it was something like a root 2 times a root 5, well, the only root 2 is here. But we now know one of those are mines. The root 5 could be here and there. I mean, I guess we can say if it's root 1, root 3, if it's root 1, root 3, then something like your root, if it's root 1 times root 10, then something like a root 8 doesn't work. But the only issue is if it's root 2, root 5, then you could have something at root 8. If it's root 1, root 3 though. Oh, then... Oh, well, then you can't have anything at root 9 or 3 away. But again, if it's root 2, root 5, then yes, you can have something that's root 9 away. And I say root 9 because it's way easier to think about those distances as being square roots. Like, it's easier to say that square root of 9 is between square root of 8 and square root of 10. This is way easier to like intuitively see than saying something like root 8 is between 3 is between root 8 and 10, which is also true, but it's a lot harder to see why until you tell it's root 9. So it's a lot easier to say that if it's root 1, root 10, then root 9 cannot have a mine in it. Yeah, in fact, if it was root 1, root 10, right, then none of those cells have mines in them, because they're all between root 1 and root 10, which means that this is a mine. Oh, which means that this isn't, and therefore if it's root 2, root 5, this is also not a mine because it's too small, it's too close. What am I saying? So this is never a mine. Oh. Oh my god. Okay, and does that 2 help? Can I click on you? No. Alright, fine. Let's look at the 2. 2 is either 2 root 2s, so either that doesn't work because this mine here indicates 1 root 10 and this is not root 10 away. So this can't be 2 root 2, it has to be 1 times root 2, times 1 times 2. And the only thing that's 1 away is here. So I guess now we are then confirming that this is root 2 times 5. Root 2 times root 5. Which means that at least one of those are mines. The 2... Yeah, well, since the 2 is 1 times 2, anything that's root 2 away is not mine. And therefore, this must be mine to finish the 10. That finishes the 2. This root 2... Well, it already sees one that's 1 away, so it cannot see another one. This root 2... already sees one that's 1 away, so it can't. This one must now see 1 there to make it multiply to 2. This 5 means there's no mine here, and I guess 8 mines remaining, so all of them are mines. Oh. Yeah, I don't know about this one, Chief. Really messed up variant. Oh my goodness. Okay, hold on. What do I do now? Let's see if we can look at the product 7. Yeah, let's try a 7 by 7. I'm gonna expect myself to have to spend 30 minutes on the 8 by 8, but we'll see. Okay, we got a lot of 2s here. Root 2s are always 1 root 2. So I guess we can start marking that there's 1 mine here. 1 mine here, 1 mine here, 1 mine here. The good thing about root 2s is that they act a lot like ones in like the normal version of X. Somewhat. They acted like the ones in the small X, you know, if you don't remember what that is. It's like where every clue tells you the things that are adjacent to them orthogonally only. I guess the 2 also means that there is 1 here. Well, I guess this 2 needs something that is 2 away, so that's a mine, right? Yeah, okay. Which means that none of those are mines. Very good. This 1 means 2 that are 1 away, but there can only be 1 mine here. So in fact, this has to be a second mine, and none of those are mines. Cool. This 2 now can't be 2 times root 2, so it has to be 1 times 2. And the only thing that's 1 away is here. Now this 2 sees 1 that's 1 away, so none of those are mines. Okay, I think it's going to get a bit messy over here, so let's remove those. I think we can set as 1 mine here. Again, this one also means there's exactly 1 mine here, so let's mark that. This root 2, don't know. This one, I also don't know. We can say that this root 2 here must have 1 that's 1 away, this root 2 must have 1 that's 1 away, this root 2 must have 1 that's 1 away, and this one, something, something, something. I guess we've made a pretty nice little block here. Root 2 is kind of fun, honestly. Fun to work with. Not very fun to actually... whatever. 2. 2 is either 2 times root 2 again, or it's 1 times 2. Let's see, how can we resolve that? None of them decide to pop up for a bit. Oh yeah, because one of those are mines, it needs another one that's root 2 away. Cool. Oh, this 2 needs something that's 2 away. Interesting. Oh, so it can't have anything that is root 2 away, which means that those are both mines. This means that's not mine. Okay, I think I can remove some stuff already. Let's remove this one. And in fact, because of this isn't a mine. This root 2 means at least one of those are mines. And because of this root 2, and at least one of those are mines, this can't be mine. Okay, I guess it didn't really help. This one, yeah, this one needs to see 2 1s, which have to be those 2. This one, I guess we still don't know. Well, I guess, yeah, we now know that there is at least 1 mine in those cells. In fact, there is exactly 1 mine in those cells, so there's no mine here. Sweet. And this root 2, well, this root 2 means there's just a mine there, so there is no mine there. Okay, I love this. It's like drilling my brain to understand what root 2 feels like. This one, we know there's a mine here, so there can't be a mine there. Cool. Okay, that's all we can do over there. So I guess now we start looking at this. This root 2 is, we know there's 1 here and there's at least 1 here. Wherever it is, it will fulfill one of those 2s in making a 1 times 2. Oh, yes, yeah, and there you go. Because one of these is going to be a 1 times 2, whichever they are, they can't see anything that is a root 2 away from them. And because this is root 2 away from both of them, this can't be mine. Whoa, that's actually really cool. Wow. Wow. Okay, so we now know that at least one of those are mines. What does that mean? I feel like saying something about this cell here, because if they were, I can't say anything about, they could, yeah, these 2 can't both be mines then. There you go, these 2 can't both be mines. Therefore, because there must be at least 2 mines in these 3 cells, there cannot be 2 mines here. This has to be a mine. Cool. And now we know that this 2 is following the 1 times 2, which means this isn't a mine. Root 2 means that one of those are mines. I don't think we know, but we do know that this 2 being a 1 times 2 can't see anything that's root 2 away, so no mine there. Therefore, there is a mine here. Cool. This one, right, so whichever mine it sees here would make this a 1 times 2. Therefore, it again can't see anything that's both 1 away or root 2 away. Sweet. Now this root 2, or if it's a 1 times 2, it's this mine is always a mine. But if it's 2 root 2, if it's 2 root 2, then none of those are mines. Is that doable? It might be. Okay. I want to know if there's anything to do with like mine count, if we have to ever make a deduction based on mine count. Yeah, what is up with this clue? I guess, what was it? If it's 2 root 2, then none of those are mines. And therefore this is mine. 2 of those are mines. How many empty cells are there? 6, 7, 8, 9. There are 10 empty cells. And only 2 of them can be empty. There you go. Only 2 of them can be empty because there are 8 mines remaining. Therefore, this can't be a 2 root 2. Because if it was a 2 root 2, both of those are empty. One of these 3 must be empty. And that will make 3 empty cells, which doesn't work. So this can't be 2 root 2. It has to be 1 times 2. So that is a mine. Anything that's root 2 away isn't. Oh, it could be 3 times. Oh, yeah, I forgot you could do that. Oh, I mean, that still doesn't explain why this was a mine and I could click on it. But okay, I guess we're starting over. Crap, I kind of forgot what I'm supposed to do here. Good enough. Yeah, this should tell us some stuff. Oh, I can click on a lot of these actually. Whoa. Yeah, a lot of these are all very brain dead things to do. Yeah, sure. This can be mine. Both of these are 1 times 2s. This means that I forgot what it means about this cell. Oh right, because there can only be 1 here, this must be a mine. There you go. There's only 1 here, so there's nothing here. There's 2. Right, so we're back where we were. And I said that this is a mine. Why? Because if it wasn't a mine, yes, okay. Because if it wasn't a mine, then there would have to be 2 root 2 because it can't be 1 times 2, and therefore you would have 3 empty cells. So I guess in that case this has to be a mine. Fair enough. Oh, and it can't be 1 times 2 because then you'd have all those be non-mines, which gives you 3 empty cells. Oh, so it is in fact it is in fact 2 times root 2 times root 2, which means none of those are mines. Oh, and we're done. Okay, there you go. Kaboom. Oh, and we're finally at +5. Oh my goodness, how long have we done this? This has gone on for about 40 minutes, so I think I can take one 8x8. Yeah, alright. 4. Okay, we haven't seen the 4 before, but we know 4 is root 16, which has a few ways of making it work. You either have this, or okay, I think I'm just gonna do that, or you have this, and we know root 8s are possible because root 8s are whatever cell is here. Okay, root 8 is whatever's here, like diagonal dash away. Or it could be 1 times root 16. It could be something like this plus something like this, but that's highly unlikely. In fact, the bigger you go, right, the bigger your radius has to be. Basically anything that is like all of those cells. And yeah, if I actually want to color it for you, every single one of those cells will no longer be mine, which is just insane. I think that's not mine either. Yeah, there's a lot of things that can't be mine because 16 is way too big. And in fact, let's look at root 2 times root 8. Oh, I clicked on so many, I can't even undo anymore. I think we should look at this though. Yeah, this must be 1 times root 2, so there has to be a mine here. 1 here means, yeah, this 1 here means there's at least 1 mine here, so there can't be a mine here, there has to be a mine here. This 2, seeing a 1 must see something that's 2 away, which has to see this one can't be mine. This 2 sees 1 that's 1 away, so it can't see another 1 that's 1 away. 1, well, at least one of those are mines, right? So this 2 is actually a 1 times 2, which means that anything root 2 away isn't a mine. That's a root 2. A root 2 in broad daylight. Right, because it's 1 times 2 and there's at least 1 mine here, there cannot be another mine here. There's exactly 1 mine here, so this also has to be a mine. 2 root 2, I forgot what that was, that's root 8. Can I click on it? Doesn't do anything. Can I click on any of these? Oh, wait, a root, yes, because root 4 can't be 1 times root 16. I mean, intuitively it can't, but like, maybe in one of the cases it can be. Like, the only reason why it's saying it now is because there's a mine here which invalidates your 1 times root 16. Okay, but whatever this is, 2 isn't going to be helping much either. All of this 4, what are our options again? 4 is either 2 times 2, or it's root 2 times root 8. What's root 8 again? Root 8 is the diagonal dash one. I don't know why I call it a diagonal dash. Just feels like a fun way to say it. What about this 2? This 2 is right. Wait. No, it could be root 2 times root 2. Because this 4 could be 2 times 2, and 2 is less than however far, yeah, because it's root 5, right, from the 4. Yeah, so technically this could work. If it was 1 times 2 though, you could have something like this, and then this 4 would see a root 2 here, we need to see a root 8, which could be like that. That's kind of whack. Honestly, that's kind of whack. I mean, maybe this doesn't work. Yeah, because that's root 5 away. Right? Wait. In fact, this 4 is just... Doesn't the 4 see everything that's root 5 away as not working? Because root 5 is between... Oh, root 5 is... Oh, this is root 4. So root 5 is larger than root 4. Oh, okay. So it doesn't work for this kind of number. Where you have a square here. It doesn't work for that. Yeah. So root 5 is possible if you had something like this. The 2 here then sees root 2, which is fine. So something that's root 5 away works. Okay. I don't think we're supposed to look at that. I think we're supposed to look at this. Again, 2 root 2 is either 1 times root 8 or 2 times root 2. 2 times root 2 feels more normal. But why? If it was 1 times root 8, then none of those are mines. Right, because root 8 is bigger than root 4. This can't be a mine either. Which breaks this root 2, which needs a 1 next to it. So it can't be 1 times root 8, it has to be 2 times root 4. Sorry, 2 times root 2. So this can't be a mine. 2 times root 2 is something that's 2 away plus something that's... So one of those are mines then. One of them is a root 2, which is a mine. Which means that this is not a mine. Which I guess means at least one of those are mines. What about this 2 root 2? Could it be... It can't be... Could it be 1 times root 8 again? If it was 1 times root 8, then your root 8 would have to be here. There will be nothing between that, so there will be nothing here. Is that possible? Might be actually, it might be possible. No, yeah, yes, because this is not in the range of that. This one is looking at root 2 times 2, and this is root 5 away. So this is root 2 times root 4, which is both less than root 5. That's so fascinating. Could this then be 2 times root 2? If it was, the only thing that's 2 away is here. And then there. Does that break? No, it doesn't. Because this could now take those cells. Oh, but it can't. Oh, wait a minute. Okay, I feel like I should think about this more than just guess and check. Where there's exactly one mine here, I should have kept that. This 2 being a 1 by 2. 1 by 2? Yeah, being 1 times 2. Sorry. No, root 2 times root 4. Cannot take both of those. Therefore, I have to take at least one of those. Right. Which now means that this 2 cannot now be root 2 times root 4 because it has to be 1 times root 8. It's 1 times root 8, which means that's a mine. And anything between that, which I think those ones cannot be mines. And now we know that's exactly one mine here. Cool. That makes this 2 a 1 times 2. The only thing that's 2 away is here, so that's a mine. This one is just mines here and there, so there's no mine there. Awesome. This root 2 means no mine here, means there's a mine there. Alright, we're getting somewhere, and I think we're finally looking at this 4 and 2 here. I'm actually very genuinely surprised that you can do anything with this variant at all. Like, wow, the root 2 is especially helpful. Alright, so 2. That thing is root 5 away. No, but root 5 is too far for us to say anything about it. Yeah, 2 will never reach that. It's either 2 times root 2 or it's 1 times 2. So, alright, maybe the 4. If the 4 was... Looking at that, it's root 2 times root 8, right? It could though. Yeah, I don't get it. What? If this 2 is a root 2 times root 2, then we know both of those are mines. This 4 therefore can't see root 8 times... This 4 therefore can't see root 8 times... times root 2, which means it must see 2 times 2. Which means something like this wouldn't work. So it sees 2 of those cells at least. But why is that bad? I don't see why that would be bad. What about if we looked at the other way around? If this was a 1 by 2, right? Then none of those are mines. One of those are mines. I guess we don't know which. Okay, yeah, alright. So, okay, let's think about this for if it was 2 times root 8. Yeah, if it was root 2 times root 8, what could it not see then? These are the things that are root 2 away. These are the things that are root 8 away. Anything within this range, any of those cells are not viable. This is root 10 away, so that's fine. This is root 5, this is just root 4, root 5, yeah. All of those are not possible if it was a root 2, root 8. This 2, therefore, can't be a root 2, root 2. So it must be a 1. Therefore, it must be a 1 root 2. Alright, if it's a 1 times 2, it has to be one of those cells, meaning none of those are cells. Alright, so we got it. If it was 2 times 8, none of those are cells. If it was root 2 times root 8, none of those are cells. If it was a root 2 times root 2, then because it can only be 2 apart, none of those are cells. Mines. None of those are mines. Jeez, what am I saying? Another root 10, okay. Well, 1 is definitely just those mines there. Which means now that this can't be root 2, root 8, because if it was, we know that all of those were not mines. So this must now be 2 times 2, which means that anything that's root 2 away isn't mine. Yeah, oh my god, it actually colors for you. It actually shades the cells that it is looking at. Oh, it shades the closest cells that it can be looking at, I think. That's smart. That's really smart of it. Anyway, this 2 means one of those are mines. This root 2. This one also, it could be 1 times 2, right? It could still have that mine there. I guess this 1 means that there are mines here. Right, so now this can't be 1 times 2 because it sees something that's root 2 away. So it must be root 2 times root 2. This one means that's no longer a mine. Yeah, it sees those 2. Well, now it means that there are 2 out of 3 of those cells are mines at least. This 10... Well, this 10 sees that, which is root 5 away. So it can't be 1 times root 10 anymore. It has to be root 2 times root 5. So meaning that none of those are mines. Yeah, I guess this is not mine also, just because we know that's root 10. 2 root 5. Oh, wait, 2 root 5 is different. 2 root 5 is root 20. Oh, crap, that's large. Not as large as, like, the things I've seen on Discord, because... I think I just phrased that horribly. Not as large as the example shown on Discord, because I've seen people actually get funny things, like square root of what, 211, which is genuinely quite atrocious. But alright, so this 10 is a root 2 times root 5, which means that only one of those are mines. Let's talk about 2 root 5. 2 root 5 is root 20, which is either there's so many ways to do it. You either have root 2 root 10, which is unlikely, You have root 3, no, you have root 4, root 5. Is that it? Oh, I think that might be it. Yeah, that's it. Okay. Yeah, these are the only factors of 20, so... Oh, it could also be 1 times root 20, but root 20 is kind of hard to get as a distance, because root 20 has to be 10, has to be 9 plus 11, 4 plus 16, so 20 has to be 4 squared plus 2 squared, which means that it would be looking at something that's this distance away. So yeah, alright, I guess we can eliminate some stuff here then. We know that this 2, 5 cannot be that anymore. It might also not be able to be 2 root 10. No, that thing is root 10 away. That thing is, because of, whoa. How do I, did my game die? No, okay, I don't know what went on there. But because of this here, it can't be 2 root 10, because if this was here, it wouldn't be counting something that's root 10 away. So it must therefore be root 4 root 5, which is 2 times root 5, and therefore, because it already sees one that's 2 away, it cannot see another that's 2 away. Cool. It also cannot see anything that's any closer, which means that now that this must be a mine, which fulfills both root 10 and 2 root 5, so that's satisfying. This 2 root 5, again, can't be 2 root 10 because it's something that's 2 away. It must be root 4 root 5, which means that this can't be mine. One of these are mines. This 2 now can't be 2 times root 2. Sorry, it can't be root 2 times root 2. I keep... Yeah, it's weird. But anyway, it must therefore be 1 times 2. Therefore, that has to be a mine, that has to be a mine. We now know that this can't be... this could be mine, right? Oh, this 4 means a mine goes there. Yeah. So now what? Wait, what? Oh, sorry, we're done. I was like, no clues, what do we do now? No, we're done. Yeah, there you go. All of these are mines. Oh. Yeah, this is a monster of a variant. I hope this variant is going to be one of the late game variants that we see in the actual game itself. Oh my gosh. But I think I've done enough Minesweeper for today. I'll see you guys next time. Bye bye.